operations vocabulary. When we have two numbers, A plus B equals C, we call A and B both addends. So A is the first addend, B is the second addend, and then we call C the sum. So the sum of A and B is C. The addends, or two addends that add up to C, are A and B. If I said something like, all right, a sum of two numbers is 5, then this was true if the first addend is 1 and the second addend is 4, or it's true if the first addend is 2 and the second addend is 3, or it's true if, let's see, 3 plus 2, 4 plus 1. I could even go so far as to say 6 plus negative 1 is equal to 5. Okay, these are all true statements. 6 is the first addend, negative 1 is the second addend, and 5 is the sum. All right, from there, let's talk about subtraction vocabulary, which I'm all of a sudden thinking I ought to go look it up, because I have a hard time remembering which is which. So A minus B equals C. And I'm going to have to stop and look this up because I can't remember which one of the words refers to which. Okay, so when we do subtraction, this first number is called the minuend. Minuend. The second number is called the subtrahend. And then C, we just call the difference. So when we subtract, we have our minuend and our subtrahend. Subtract the subtrahend from the minuend, and that gives us C. But for addition over here, we call both numbers addends. Why do we need different numbers to describe the first number and the second number when we do subtraction? And that's a very good question. So let's see what happens if I reverse two addends. So if I take a number like, let's see, I'll go with 3 plus 2 gives me 5. Okay, now if I go and reverse them, Larry, please stop that. If I reverse them, I get 2 plus 3 equals 5. All right? And what this tells me is that it doesn't matter which order they come in. The two addends can be switched, and I get the same sum. And this is an example of the commutative property. Commutative property for addition, which means changing the order of the addends doesn't affect the sum. But if I try the same thing then with the minuend and subtrahend, let's go with 3 minus 2 is equal to 1. And 2 minus 3 is equal to negative 1. I see I don't get the same thing, which means that there is no commutative property for subtraction. It doesn't apply. Okay, 3 minus 2, 2 minus 3. But if I take my minuend and subtrahend, and if I write this like it's a sum, and so I say my minuend becomes my first addend, and then I take my subtrahend and make the negative of the subtrahend, So negative second addend. And rewrite it, what I'm gonna get is that A plus, and then I'm gonna say negative B is equal to C. All right, so now I'm gonna say C is a sum, not a difference. And when I do this and write it out as 3 plus negative 2 equals C, or equals, I'm sorry, 3 plus negative 2 equals 1. All right. So now, here's my first addend, and here's my second addend. When I rearrange these, I'm going to have negative 2 plus 3 equals, so negative 2, add 3 to it, gives me positive 1. All right, so I'm back to the commutative property. And that's part of the reason why we have different names when we do a subtraction, different names for those terms. It's also a very important point about subtraction being addition of a negative, because if subtraction is addition of a negative, then I can always write it as addition and the commutative property applies.